This video will describe an inelastic collision, a football play. It's not good football technique, but it's a physics example. We have a 100-kilogram linebacker who's watching an 80-kilogram halfback running towards the line of scrimmage. The halfback has a velocity 8 meters per second directly towards the line of scrimmage. The linebacker has a velocity of 5 meters per second towards the line of scrimmage just before they collide. So, concept question first. What do we need for conservation momentum to be true? Will it be okay if both players jump in the air and then the tackle is made in midair? So both players are not in contact with the ground. And yes, this will be true. Ignore air resistance. But there's no net external force on the two players, so momentum will be conserved. This is bad football technique. Listen to your coach and put your feet in the ground and drive, and contact is imminent. But physics problem. They're both in the air, and they're separate objects before the collision takes place. When the collision takes place, the linebacker tackles the halfback, and we just have one mass after the event takes place. We're going to conserve momentum by calculating mv, mass times velocity, for each player. So they have the halfback, we have the linebacker. Notice that the linebacker's velocity is negative. I'm taking positive to be the direction that the halfback is moving. So we do have a net momentum before the collision takes place, 140 kilograms meters per second. Afterwards, there's just a single object. So we add the two masses together, the two players, and we want to calculate what's the final velocity. Well, we've calculated the velocity before the momentum before the collision, 140 kilograms meters per second. We have mv after the collision. We divide both sides by 180, and we find that the halfback is continuing to move forward here. Both individuals are moving off to the right, 0.78 meters per second. So what made that happen? Why did the linebacker not stop the halfback? Well, the halfback has more momentum, 640 units of momentum off to the right. The linebacker, 500 units of momentum back to the left. The halfback dominated the system, and the velocity continues to the right until some more defensive players grab on here and complete the tackle. But that's an example of an inelastic collision. There was no rebound. We have the objects sticking together after the collision. That's a clue that you have an inelastic collision. They're not hard to solve. As long as you can verify the momentum is conserved, that there's no net external force. You calculate momentum before the collision. You calculate momentum after the collision. There'll be an unknown someplace in the problem, and you're well on your way to solving it.